we ended by talking about the fact that the biggest difference between the mean and the median is that the median is more resistant to outliers or skewed values or extremely high or extremely low values. And we showed that with the example of having this list of data and saying that this big number here would change the mean by a lot, but it wouldn't change the median. And so if we wanted a more typical measure of a measure of center that says what's the typical value in this list, then the median is going to be better off for us. So that's the idea of a resistant measure. And we're going to talk about measures of spread being resistant as well. So we have extremely high or extremely low values, then the mean is going to cater a lot more to those values because of how we calculate it. And that's what we ended talking about yesterday, to put it another way. So today we're going to talk about spread. But before we do that, we have a new word, which is quartile. Okay? It is a similar idea to the median. It's a similar idea to the median, which is the median basically splits the data in half. But I could take those halves of the data and split them in half again, and now the data is split into quarters. We have lower quarter, the lower middle, lower high, and highest. So we basically have 0 to 25% of the data, 25 to 50, 50 to 75, 75 to 100. Instead of lower half and upper half, it's splitting the data into quarters. And the first quartile, Q1, separates the lower 25 from the upper 25. The next quarter of the data would be Q2. It would be the median. That's what splits the data in half. And then we have Q3, which splits the upper 25 from the lower 75. And to find the quartiles, we're going to do the same thing that we do from the median. So basically, we've cut it in half to find the median. We're going to cut it in half again to get the quartiles. Anyway, so if we have a list of data, we would take the list and split it until we found the median. But then we could go from the median and split that in half and make that list and figure out what the middle number is of that list. So I got 2, 4, and 4. The middle number would be 4. I've got 1, 3, 3, 4, and 5. That middle number would be 5. So that's the first quartile. Here's the third quartile. And you're not going to have to do this very often, but you should, again, just like with the median and the mean, you should know how to find these numbers and how the process is for finding these numbers and how that works. Question?
When you're referencing the quartiles, like for example, the third upper quartile, do you include the 7?
Do I include the 7? We'll talk about what that is in just a second. Okay. I want to. The next slide should help with that. Okay. What we do with these quartiles is we put the number into what's called a 5-number summary. A 5-number summary. It is kind of a quick glance of what the data looks like. The 5 numbers that are there are going to be, I'll list them off kind of vertically. They're listed off here, but it'll look like minimum, the smallest number, Q1, the median, which is Q2, Q3, and the maximum. And this gives us a quick glance of what does the lower bit of the data look like, what does the higher bit of the data look like, where is the middle of the data. So we can take these 5 numbers and put it into a visual, into what's called a box plot. You might also see it called a box and whisker plot. And again, this is what it looks like. Here's the minimum, Q1, the median, Q3, and the maximum. So Q2, the median, is the line that divides down the box. The borders of the box are the quartiles, and then it's called the box and whisker plot because these are the whiskers. At the ends are the minimum and the maximum. Question? Correct. Correct. Q1 is I take all the numbers between the minimum and the median, split them, and find the middle of that. That's Q1. Q3 is I go between the median and the maximum, and then split that data in half. That's where Q3 is. Now, how about your calculators? And I want us to, we're going to use the same list of data we were using yesterday. So if you already have that in list 1 of this data. And you'll notice at the bottom of this, we had our sample size. We said this was the mean, X bar. We've talked about that already. But now you should recognize the 5-number summary. Here's the minimum, Q1, median, Q3, maximum. It'll keep track of it for you. So this is not something you'll ordinarily have to compute, but you'll need to know how the quartiles work and what they represent and be able to interpret them. So this tells me that a quarter of the data is between 1 and 5. A quarter of the data is between 5 and 13. A quarter of the data is between 13 and 17. A quarter of the data is between 17 and 23. Half of the data is between 13 and 23. Because remember, it splits it into upper half and lower half. Half of the data is between 5 and 17, between Q1 and Q3. And we can actually use this to make some graphs. So go to second, y equals. These are your plots. You've probably used this menu. You might have used this menu before to make scatter plots, but that's not what we're going to do today. We're going to turn it on. And it asks for the type. And you can have a couple different things. We'll talk about what this one is at the end. But the main ones we're going to use are, we have this one, which is going to be your scatter plot. This one we're not going to use. This you should recognize. What is it? Not a bar chart. It's a histogram, because we're using the data in the list to get there. That's quantitative data. And then these are your box and whisker plots. You're going to normally want this option here. And we'll talk about why in just a second. Zoom 9 is zoom stat. So I'm going to go zoom, hit 9, and that should show you the box plot. You can also select the histogram, hit zoom 9, and it'll pop up a histogram for you. So if you got a bunch of data, put it in list 1, have it make a histogram. Correct. But it should have a scale. You should know, here's the minimum, and it was, what was it? 1. So this is 1. and here's the median. It was 13. So that should give you an idea of where the scale is. You can also have it make a histogram for you. Now, there are two different measurements we can make of spread with this box plot. Okay, one of them you should be familiar with. It's if I went from n to n and figured out what's the largest value, what's the smallest value, how far apart are they. This is called the range. Take the maximums minus the minimum. That's range. This is not, we just talked about a resistant measure of center. This is not a very resistant measure of spread because, again, think about if this number suddenly turned out to be 23 trillion and was all the way over here. Well, it'd be way farther over there, but it would be over there. Then, how far apart the numbers typically are, that doesn't give you a very good measurement of it. So what we're going to do instead of taking the largest and smallest values, which may not be a good idea of what the typical value is and how far apart most of the numbers are, is we're going to take the middle 50%. We're going to use the quartiles. We're going to take the distance between the quartiles, between quartile 1 and quartile 3. And this is called interquartile range. Which we abbreviate IQR. This is in the next slide, by the way. Or it should be in the next slide, hopefully. But this is just to visually show you the difference. And this is the measurement of spread that we're going to get from a box plot. And it's going to be, this is quartile 3 minus quartile 1. And visually in the box plot, it's going to be how wide is the box. That's basically what the interquartile range is. It also says where the middle 50% of the data is. Because there's half the data in between Q1 and Q3. And it's the middle half of the data. So it says how far apart that middle half is. So to recap all that. For spread, the length of the box is the interquartile range. Length of the entire plot is the range. Both of these answers are one number. We don't say the range is from 2 to 9. We take 9 minus 2 and say the range is 7. We say the interquartile range, IQR here, would be 7 minus 4. Q3 is 7, minus Q1 is 4, which is 3. So the interquartile range there is 3. So IQR here would be what? We would take Q3, which is 17, minus Q1, which is 5. That's 12. So that's one measure of spread we're going to use, is interquartile range. I'll come back to this in just a second. The other measure of spread we can use is standard deviation. Standard deviation. This is with the Greek letter sigma or S sub x. These two are both used to stand for standard deviation. And You will not have to compute standard deviation. Again, the calculator does it for you. It is S sub x right here. This would be the standard deviation of the data we put in list 1. You will not need to do this formula, except for I'll have you do it 1 or 2 times on the homework, just so that you can see what it looks like. We'll do it once, and then once or twice on the homework, and then I won't ask you to do it again, because the calculator will do it for you. So I'll probably do that on Monday, Tuesday, have you compute it. Okay. We have interpretation of standard deviation. Is the average deviation from the mean. Another way to say it, I might put the word distance in there instead. The average distance from the mean. So we look at, it's basically a way of saying how far apart, how far away are the numbers on average from what the mean is. So we calculate the mean, and figure out how far away each number is from the mean. And that's how it gets factored into our standard deviation formula. And since we're measuring how far away numbers are from the mean, that's a measure of spread. It's a way of measuring how spread out the data is. Again, we'll look later on at actually doing a standard deviation and seeing how it's calculated. We'll do that on Tuesday. Or at the end of the hour if we have time. We'll see. But I want to get to going back. We did that. We did interquartile range. Interquartile range and the quartiles are going to help us determine if there are any outliers in a set of data. That's what we're going to use to test if something is an outlier. So we're actually going to use the quartiles as our boundary. And then we're going to move to the left or right of those quartiles this distance. 1.5 times the interquartile range. So we start at one of the quartiles, we move that distance. If a value is farther away than that distance, then we have an outlier. So let me show you what that looks like. Let's actually do it with an example here. With the same list of data that we had before. If we are looking, we have IQR. We decided that was 12. So 1.5 times the IQR. That's going to be 18. This is our distance. Our boundaries are the quartiles. So let's start on the upper end. Let's look for an outlier above. 1.5 times the IQR is 18. So 17 plus my 1.5 times the IQR is 18 equals 35. Any value that's above 35 in the list is an outlier. Q1, 5 minus 18 is negative 13. So anything below negative 13 in my list would be an outlier. So we've got no outliers here because the smallest value is 1, the largest value is 23. And that gives me a boundary to use to cut off and say above here and below here are outliers. And if we have outliers, then what we can do in the box plot then we'll have our, this is an example from out of the book, then we'll have our smallest and we'll have our largest, but we'll extend our largest thing that isn't an outlier, and that'll be the end of our box plot. And then the outliers will be dots. That's how we put outliers. And that's why when I said we were going into our stat plot, that's why we selected that option. Because, again, that will have the calculator do it for us. That will have it show, here are the values. Here's the box plot with the outliers plotted separately. This would give the box plot and ignore testing for outliers at all. So this is the one we want to select most of the time. Let me put that up on the board. I'm going to focus on doing some examples tomorrow. Because I want to finish up these notes. And we're going to take this over the next couple days, including tomorrow. We're going to take this information and put it all together and have you describe a distribution using what's the shape look like, what's our measure of center, what's our measure of spread, and are there any outliers? And you should be able to give me a few sentences and collect the data to describe and use each of those things. So we're